Today we're going to be talking about ionic, covalent, and metallic bonds. So before we look at that, we're going to review the octet rule and valence electrons. An atom's outermost electrons are known as its valence shell electrons. So only these valence electrons are given, taken, or shared in a chemical reaction. The group number tells the number of valence electrons. So group 1 has 1 valence electron. Group 7 is going to have 7 valence electrons. And group 8 has 8 valence electrons. These are the noble gases. So they have a full outer shell, and this is why they are inert, and so they do not react. So the octet rule states that having 8 electrons in the outer shell makes an atom stable. And atoms will either gain or lose electrons so that they have 8 in that valence shell. So here's an example. Magnesium. So find magnesium on the periodic table. So it is a group 2 element, which means that it has 2 valence electrons. And since it's on the left side of the periodic table, we know that it is a metal. So magnesium will give 2 electrons, both of those 2 valence electrons, becoming positive, making it a cation. So pause the video and try example 2. So find bromine. It's a group 7 element. This means that it has 7 valence electrons. Since it's on the right side of the periodic table, this means that it is a nonmetal. And nonmetals take electrons. So it's going to take 1 electron and become negative. And bromine is an anion. So let's talk about some exceptions to the octet rule. The first one is that there is an odd number of valence electrons and the molecules can't form an octet. So one example of this would be NO2. So nitrogen has 5 valence electrons, oxygen has 6, but there are 2 oxygens, so we have a total of 17 valence electrons available. So that's not enough for a full octet. So we're going to draw the Lewis structure. So we start with nitrogen in the center, and we add our 2 electrons to show the bonds. Then we put electrons around the outside of each oxygen. So right now, we have 16 electrons. And then our last one will just go by nitrogen. That gives us our total of 17 electrons. So our second exception is suboctets. These are stable configurations that have less than 8 electrons around an atom. So our example is BH3. So boron has 3 valence electrons. Hydrogen has 1, but we have 3 hydrogens. So we have a total of 6 valence electrons. So we put the boron in the center and our hydrogens around it. And then we put 2 electrons between each of the hydrogens and boron to show that bond. And so each of the hydrogens has a full shell because it can only have 2, but boron only has 6. Our next example is coordinate covalent bonds, and these form when 2 electrons from one atom are donated to an atom that needs more electrons to be stable. So atoms that have lone pairs of electrons are the ones that are going to do this. So for our example, we have BH3, which had a suboctet, plus NH3. So BH3, we've already drawn. So we have our boron with the hydrogens, 3 hydrogens around it, and 2 electrons between each hydrogen. Now we have the N with H's around, and we can draw our bonds between each of those. And this has a lone pair of electrons. So that lone pair is actually going to be shared between the nitrogen and the boron. So we'll draw that again so that we can see the two electrons being shared. So our fourth exception is expanded octets. So this happens when compounds have more than 8 valence electrons. So an example of this would be PCl5. So we have phosphorus and 5 chlorines. So phosphorus is in group 5. It has 5 valence electrons. Chlorine has 7, but we have 5 chlorines, and this gives us a total of 40 valence electrons. So we put our phosphorus in the center and our 5 chlorines around it. And then we can draw a line, and that line will represent 2 electrons and shows that there is a bond. Then we start filling in with our electrons around our chlorines. And so if you count them all, you'll see that there are 40 valence electrons total. Each chlorine has 8, and phosphorus has 10. So now we're going to talk about the types of bonds. So there are 3 main types that we'll talk about. But first, a chemical bond is what holds atoms together. And these bonds are formed by the attraction of the positive nucleus of one atom to the negative electrons of another atom, or by the attraction of the positive and negative ions. So when 2 or more atoms are giving, taking, or sharing their valence electrons. So the difference And the electronegativity determines what type of bond will be formed. So remember that electronegativity is the measure of the tendency of an atom to attract a bonding pair of electrons. So how much an atom wants more electrons. So if there is a small or no difference in electronegativity, then the electrons are going to be shared equally. This is called nonpolar covalent bonds. So if there is a medium difference in electronegativity, then the electrons are still going to be shared, but unequally. This is called a polar covalent bond. If there is a large difference in the electronegativity of the two atoms, then the electrons are going to be given or taken. So this is ionic bonds, and this is what happens between metals and nonmetals. So ionic bonds, again, this is between metals and nonmetals. So the electrons are given or taken. Metals are going to give, and nonmetals are going to take electrons. So ionic bonds occur when there is a large difference in electronegativity, and one atom takes the electrons from another atom. And one ionic particle is called a formula unit. In these type of bonds, the electrons are not shared, but the particles are still held together by the opposing charges. And this is called electrostatic forces. So our first example is NaCl. So Na is group 1, it has 1 valence electron. Chlorine is group 7, so it has 7 valence electrons. And we can draw those around the chlorine. So Na is going to give that 1 electron to chlorine. So we put it in brackets because it is an ion. Since it gave away its electron, it now has a plus charge. Chlorine now has a full octet. It has 8 electrons. So we'll draw those around. And it is also an ion, so it has to be in brackets. And since it gained 1 electron, it's negative. So we have to put the negative charge. So our next example is K2S. So we can find potassium on our periodic table. And it's group 1, and sulfur is group 6. So it has 6 valence electrons. We'll draw those around it. And you have your 2 potassiums on either side of your sulfur, and each one had 1 valence electron. So draw the 1 valence electron for each potassium. And those are both going to be given to the sulfur. So we can rewrite this. And sulfur will have, it's going to take both of those electrons from the potassium. So it will have 8 in its valence shell. Again, we have to put it in brackets because it is an ion, and it has a -2 charge because it accepted 2 electrons. So now we can draw the potassium, and it also has to be in brackets because it donated 1 electron, which gave it a +1 charge. So each potassium now has a +1 charge. So our next example is CaO, calcium oxide. So calcium is a group 2 metal, so it has 2 electrons. We can draw those. And oxygen is a group 6 nonmetal. It has 6 electrons. So we'll draw 6 electrons around the oxygen. So calcium, since it's a metal, will donate its 2 electrons to oxygen. And it will become positive, so we'll draw it in brackets because it's an ion. It now has a 2+ charge, and oxygen, since it accepted those electrons, has 8 in its valence shell. So we'll draw all 8 of them. And oxygen has a -2 charge. Some properties of ionic bonds are that they have regular repeating crystal lattices. And so you can see that they have this repeating pattern over here in the picture, and they form these crystals. They also are hard, brittle solids at room temperature. They have high melting and boiling points, and they can conduct electricity whenever they're in a liquid state or in solution. So they will not conduct when they're solids. So covalent bonds. There are 2 different types of covalent bonds, and these are formed when the electrons are shared between 2 nonmetals. And this is kind of like a tug of war between the 2 electrons, or the 2 atoms with the electrons. So these are shared between 2 nonmetals. So nonpolar covalent bonds are when the 2 nonmetals are sharing the electrons equally. And this is because they either have an electronegativity that is the same or it's very, very similar. So they're pulling on those electrons the same amount. So one example of that would be Cl2. So we can find Cl on the periodic table. It's group 7, and it is a nonmetal. So it has 7 electrons in its valence shell. So we can draw that with our electrons, and we would draw 7 electrons around each of our chlorine. then we can draw a line between the two chlorines to show that there is a bond. And then we'd put our rest of our electrons around the outside of each of those chlorines. So since these are the same element, we know that they're going to have the same electronegativity. So our next example of a non-polar covalent bond is carbon and hydrogen bond. So carbon is group 4, hydrogen is group 1. We'll draw a line between them to show that bond, and that's the sharing of 2 electrons. And then we have 3 electrons left, which will go around carbon. So you would see this in an example like methane, which is CH4. So the next type of covalent bonds are polar covalent. These are nonmetals because all covalent bonds are going to be nonmetals, but they share the electrons unequally. So one atom has a higher electronegativity than the other one. And this creates more positive and more negative areas within the molecule. So an example of that would be water, which is H2O. So we have our oxygen and our 2 hydrogens. Oxygen has 6 electrons, hydrogen has 1. And so we draw our bonds between the oxygen and each hydrogen. And we have our hydrogens now have a full shell because they can only have 2. And then we have 4 extra electrons that would go around the oxygen. And since oxygen is much more electronegative than hydrogen, it's going to hold the electrons closer. So hydrogen will be slightly more positive, and oxygen will be slightly more negative. This is the sigma sign, and so it's saying sigma positive for hydrogen and sigma negative for oxygen. Our next type of bonds are metallic bonds. So this happens between metals and alloys. So the electrons are free to move, and they're mobile. The metals themselves are going to form a lattice in the solid state, and they have a sea of electrons. They don't necessarily share or lose their valence electrons, but the electrons just move around, and this creates a sea of electrons that surround the positive metal atoms. So this is why metals are strong but still can be flexible. And it's also why they have such a high thermal and electrical conductivity. They're also malleable, which means that they're able to be hammered into shapes and not break, and ductile, which means that you can form them into wires. So now practice identifying ionic, covalent, and metallic bonds. So our first one, NABR. We can use our periodic table, and we see that Na is in group 1, and Br is in group 7. So this tells us that we have a metal and a nonmetal, so it is an ionic bond. Ionic bonds are called formula units, and the electrons are given or taken. our next one is F2, fluorine. So fluorine is in group 7. It's a nonmetal, which means that it is covalent. And since it's 2 fluorines, that would make it nonpolar covalent. So the type of particle would be a molecule. And the electrons are going to be shared equally. So our next one, CH3Cl. Carbon is a group 4. Chlorine is group 7, and hydrogen is group 1. So this would be all nonmetals. So again, this would be covalent. But this time, carbon and chlorine have a big difference in electronegativity. So this would be polar covalent. The particle is still a molecule. The electrons are still shared, but this time they're shared unequally. Now we have aluminum. So that is a metallic bond. Those are just atoms. And the electrons are in a sea of electrons. So our last one, we have copper, tin, and zinc. So these are all metals, and this is also a metallic bond. But this time, this is an alloy. And it's still a sea of electrons. So pause the video and try to figure out which kind of bonds each of these molecules have. So the first one is ionic. That is a formula unit. And they have a give and take of electrons. This is a metal and a nonmetal, so it is ionic, a formula unit, and that is give and take of electrons. Au, that's gold, and it is a metal, so that's a metallic bond. Those are atoms, and they have a sea of electrons. SCl6, that is covalent. Those are molecules, and the electrons are shared. SeO, those are both nonmetals, so that is polar covalent. Those are molecules, and the electrons are shared unequally. HCl, those are both nonmetals, so polar covalent. It's a molecule, and they are shared unequally. KOH. This is ionic. It's called a formula unit. And they are given or taken. SN, that's 10. So that is a metallic bond. Those are atoms. And there is a sea of electrons. CH3OOH, this is vinegar, and it is polar covalent. It is a molecule, and the electrons are shared unequally.